one more, the length of the external common tangent and internal common tangent to two circles. What is the meaning of external common tangent and internal common tangent? And in the diagram itself, it is clearly seen. If you want to see the diagram is given here clearly. This AB is said to be, the length of the direct common tangent. How do we say that? It is direct common tangent, and if the two circles are lying on the same side of the common tangent, it is said to be the direct common tangent. And if the two circles are lying on either side of the common tangent, then it is said to be the indirect common tangent or transverse common tangent. The length of the direct common tangent, you can see it is root over d square minus of r1 minus r2 whole square, and the length of the internal common tangent, or you can say indirect common tangent or transverse common tangent. There are three different names: length of the internal common tangent, a length of the indirect common tangent. This is, he's saying it as external common tangent. Direct common tangent, external common tangent are same. So internal common tangent or indirect common tangent or transverse common tangent, if this name is used, this word is used, you have to understand that it is one and the same. Root over d square minus of r1 plus r2 whole square. Okay. So in both these cases you have to understand that, this d must be greater than r1 plus r2. That is, distance between the centers must be greater than the sum of the radii, then only the two circles will never intersect each other. And it is very simple. Let me show you how this length of the direct common tangent is proved. Let me show you that. This is like this. Let me take a circle. For better understanding. Okay, now let me take a smaller circle. This is a smaller circle. Okay, now what I need the length of the direct common tangent. So let us choose this one, the direct common tangent. Direct common tangent is that tangent which touches both the circles, and as well the circles must be lying on the same side of the common tangent. The circles must be lying on the same side of the common tangent. Now, we need the length of this. Let me name this, but before that, let me show you the radius. This is center. This is radius 1. This is radius 2. Okay, so let me join these centers. Now, if you drop a perpendicular here from this, or if you draw a line which is parallel to the line of centers. You draw a line which is parallel to the line of centers, like this. Okay. Now, let me name this. This is length of direct common tangent. As given here, I am naming this as AB. This is C1, this is C2, and obviously this is R1, this is R2. And you have to understand that the total length is R1 here, and this length is R2 here, and these two are parallel lines, and this is nothing but distance between the centers denoted by D, and obviously this is also D, and this is 90 degrees as you know, because the line joining the center and the point of contact, the line joining the center and the point of contact of any tangent is always perpendicular. So this is R1. Now what will be the length of this? This part here, let me say this as something like D. Then the length of this part will be, the total length is R1, and the length of this part will be R1 minus R2. This is R1 minus R2, this is D, this is the side which is opposite to 90 degrees, and hence it is obviously the hypotenuse. So apply the Pythagorean theorem here, that is square on the hypotenuse, that is D square minus R1 minus R2 whole square. So by applying the Pythagorean theorem here, D square minus of R1 minus R2 whole square, you will get the length of the direct common tangent. That's what is given here, root over D square minus of R1 minus R2 whole square. In the same manner, you can derive the length of the transverse common tangent, or what he is saying is internal common tangent. Also, using the same method, in place of R1 minus R2, you will get R1 plus R2, because the circles are lying on either side of the common tangent. Just you can check it out. This is the transverse common tangent. The circles are lying on either side of it. So this is about the length of the direct common tangent and the length of the transverse common tangent. Let's move to the next part of it. That is